All right, for this problem, we're asked to evaluate this line integral along this curve. All right, so to do this, this line integral, what we need to do is put this expression, xz plus y squared, we need to put that in terms of t. And we're going to use this, this curve, the parameterization here, to put this in terms of t. And then this ds is going to be equal to the magnitude of dr dt, or the magnitude of the velocity. If this is the position vector, the magnitude of the velocity times dt. So using this this curve here, the x component is going to be negative 10 minus 2t, y is equal to t, and z is equal to negative 2t. All right, and then dr dt is going to be equal to negative 2I plus j minus 2k. So the magnitude of dr dt is going to be equal to the square root of this squared, so 4, plus 1 plus 4. So that's going to be the square root of 9, which is 3. So what we found so far is the magnitude of the derivative of the position vector. So the magnitude of the velocity vector. And now let's put this in terms of t. So if we've got x times z, here's x, so negative 10 minus 2t. We're going to multiply that by z, which is negative 2t, plus y squared is just going to be t squared. And that's going to be negative 2t times negative 10 is 20t. Negative 2t times negative 2t is 4t squared, plus another t squared is going to be 5t squared. So now what we have is we have this expression here in terms of t, and we're going to multiply that times the magnitude of dr dt, and then times dt. And then we can set this up as just a straightforward single integral, and then evaluate that. So this is going to be the integral from 0 to 1. So remember, t is between 0 and 1. From 0 to 1 of this 20t plus 5t squared times 3 dt. All right, now let's evaluate that, and we'll be done. So let's go ahead and put this 3 out front, and we'll evaluate this. This is going to be 10t squared plus 5/3 t cubed, and we're going to evaluate that from 0 to 1. So if we plug in 1 here, we're going to get 3 times, that's just going to be 10 plus 5/3. And obviously if we plug in 0, we'll get 0. So this is going to be 30 plus 5, so 35 is going to be our answer for that line integral.